Hello everyone. Today we'll be talking about conic sections in chapter 8. So basically, conic section we'll be talking about three items: parabolas, ellipse, and hyperbola. In the first topic today, section 8.2, I'll be talking about parabolas. I'll show you a new approach to a parabola. So first, let's start with the definition. Given a point F and a line D, a parabola is a set of all points P such that the distance, let me denote it by DIS, the distance from P to F is equal to the distance from P to D. Okay, that's the definition. So let me clarify the definition using geometry. So basically what you are given is a point F and a line D. Okay? We are looking for all the point P's. There's a lot of point P's on the plane. Satisfy the condition that they give you right here. Point P right here. But distance from P to F is that long. Distance from point P to the line D is that long. I'll draw it better. That long. Okay. And you are looking for all the point P's to satisfy the conditions. We have a lot of point P's. And another point right here. Same distance. Another point right here. Same distance, right? Many points P to satisfy the condition. And then you're going to connect all the points P that have the same distance from P to F to P to line D. You're going to have a curve. Okay? And that curve, now we're going to call it a parabola. Okay? So actually we learned about parabola before. We think of it as a function, a y equal to ax squared plus bx plus c. Now we have another approach to parabola using conics, and we define parabola using geometry given two things fixed: a point F and a line D. Okay, and later on you guys know the F stands for the focus of parabola, and line D, F here is focus, and D stands for directrix. So from now on we're going to call point F as the focus of parabola. And the line D is called the directrix line for the parabola. Okay? So before I move on to show you some equation to work with mathematically, I'm going to talk about some use of parabola and some cool properties of it. Alright, so let me erase that part. Let me try to redraw the parabola right here, make it straight on the board. See that we have two things, right? This point right here is focus F, the line right here directrix D. And parabola has only one property, is what any point on the parabola will have the same distance. Okay, that line will be equal to this line. Alright, so as you know before, this point right here in the middle, we call it the vertex of parabola, this V vertex, okay? The distance from V to F is that much. Alright, and of course, by our definition, the distance from V to F is going to be the same as distance from V to the line D. So V is going to be right in the middle of the point F and the distance, and the directrix line D. Okay, P is going to be right in the middle. And this is the shorter distance from a point on the parabola to the focus, or a point on the parabola to the directrix line. Any other points on the parabola will have a longer distance. Okay? And we're gonna label or name or call this shorter distance as little p. Okay? This is a capital P for stand for point. And this is a lowercase p stand for the distance from the focus to the vertex. And this is also the distance from the vertex of the line D because they got the same distance. Okay? vertex right here. You know what? This line right here, as we learned before, is the line through the vertex and perpendicular to the direction line. This line called the axis of symmetry. And that means that the parabola will be symmetrical about that dotted line right there. Okay. One more thing about the parabola. Okay. If you try to draw a line that goes through the focus and perpendicular to the axis of symmetry, or parallel to the directed line, okay? That line gonna intersect the parabola at 2 points, and you have a line segment, and we have a name for that line segment. That's called the lattice rectum. Okay. One more time, the lattice rectum is the line segment from here to here. The line that goes through the focus and parallel to the directed line or perpendicular to the axis of symmetry. Okay? The line segment from here to here. You know how long that line segment is? It's going to be 4p. Why? Use geometry all the time, right? So if you call this point P, distance from here to here is going to be equal to distance from here to here. Okay? Distance from here to here will be equal to that distance from here to here. This is right in the middle, so this side right here will be equal to that side right here. This equal to that. And how long is this one right here? 2p. This is 2p. This is 2p. So this is 2p. This is 2p. It's called a Q. So the line segment PQ is going to be equal to 4p because QF is 2p and then FP is another 2p. So the lattice rectum length always equal to 4p, where p is the distance from the vertex to the focus. That line always be 4p. So if this is 1, it's going to be 4. If this is 10, it's going to be 40. Okay, and you know that if the bigger the value of p, then the wider the parabola is going to be open. All right, that's basic property. Some information about this. Let me show you some application and some use of it. Let me redraw the graph. So basically we have a parabola, we have the focus right here, and now let's explain to you how we're going to call it focus. One problem is this. Oh, by the way, this is the directed line. Okay, if you have any line, think of the parabola as like a mirror. It's coated, okay, outside, so it will reflect the light. Okay, if you have any light beam that is going to the parabola and perpendicular, that light beam will be perpendicular to the directed line, and that light beam will always reflect back to the focus, always. Okay, any perpendicular to the directed line. This is my director's line. Okay, this is my focus. Everything always reflect back to the point F. That's why, because that's why we call F the focus point. What's the use of it? Say, think of the headlight of your car. If you put the light bulb right here, okay. So you have a light bulb right here. And what happens when you turn on the light? All the light come out, point forward. That's why you see things. Or say you're gonna make fire. They have some sort of energy, say the sun right here, right? And you wanna have fire. You wanna have a piece of foil, fold it that way, like a parabola, right? And then point it to the sun, and the heat from the sun will reflect everything. Is one light beam gonna have a little heat. But all of them focus on one point is gonna be very hot. Okay? You put some tinder right here. It's gonna burn. Okay, let me see if the book gives you any other application of it. Oh yeah, one more. Let me read the book. Say you have TV satellite, right? Have a disc, right? Parabola, literally three-dimensional parabola, okay? Called paraboloid, okay? And your disc gonna point into the satellite, and you gotta see some stick like this, right? And this point right here is actually the focus, and the satellite up there gonna send a signal, get to the disc, and all the signal will reflect back right into the focus point, and have a cable get to your TV, and we're gonna have the signal. Okay. Now here comes the main part for parabola. I'm gonna show you some equations for parabola we're gonna learn in our course, and help you to do practice some exercises. So basically, we're gonna learn 4 types of parabola equations. Okay. So item number 2, equations. Let me start with this one, parabola that's pointing upward. Parabola look this way. Vertex right at the origin. Of course, if it's pointing upward, the focus, let me draw it better, a little bit better. Focus is gonna be right here, F right here. This is the x-axis, this is the y-axis. If parabola pointing this way, vertex right at the origin, point F up there, and the direct line gonna be down here. So this point, F right here gonna be at 0, comma P. Right up here, 0, comma P, and the point right here for the intersection between the directed line and the y-axis is at negative P. Okay, so this point right here is at negative P, 0, comma negative P. The equation for this parabola is going to be 4py equal to x squared. This is the little p that I'm talking about. Okay, and then the second parabola. Same thing now, it's gonna open downward. So this is a vertex of the origin, and this is the x-axis, this is the y-axis. So this time the point P is gonna be right here. Director's line gonna be up here. Okay? And focus is gonna be at 0, negative P. And this point intersection is gonna be positive P. Okay? The equation for this parabola will be 4py equal to negative x squared. You see the difference in the first equation and the second equation? We just change the sign. Many people don't write negative sign in here. They can write a negative sign on the other side. Doesn't matter. It's the same thing. Just simply multiply -1 on both sides. Okay. And then the third one. This is open up. This is open down. Now I'm going to show you another one that open to the right. Parabola this way. Okay. So the focus now is going to be on the right. The director's line going to be on the left. Okay. So the point F now is at P, comma 0. You see the coordinates changing. This is 0P, right? 0 for X, and Y is P, and this is P, comma 0. And this intersection point right here is going to be negative P. So this point is at what? Negative P, comma 0. And the equation for this one is going to be 4px equal to y squared. Okay, see what we're changing? Right. 4py squared, but I'm sorry, 4py equal to x squared. This one is 4px equal to y squared. Okay. Of course, it's not a function anymore, but we're not talking about function at all today. We only talk about parabola. Okay, could be a function. Like the first 2 examples may not be a function. Like the third one, but they are parabolas. Okay. And of course, you learn by similarity. We have the fourth one for today. Parabola that open to the left. All right. With this one, director's line going to stay on the right hand side. Focus point P, F is right here. This point is at what? Negative P, comma 0. Origin is right here, which is vertex. So we don't read it. This is P, it's x-axis, the y-axis, okay? And you can guess the equation for this one will be negative 4px equal to y squared. Those are the 4 basic equations for parabolas that you guys will be learning in this section. Okay? They have one point in common, the vertex. The vertex of all 4 parabolas are always at the origin. Now, we're going to extend the concept a little bit more general. What if we shift the entire parabola to a new vertex? So in here, the vertex is at, let me write somewhere in here, let's see. Here the vertex is at 0, 0, right? Now I want to change to a new vertex at, say, h comma k in general. Okay? So we shift from 0 to h for the x coordinate, we shift from 0 to k for the y coordinate. What do we need to change to shift the vertex? Shift the vertexes. We change x to x minus h. We're going to change y to y minus k. Then the vertex is going to be shifted. Okay? And just in case it's not quite clear what we're talking about in here, I will refer you guys back to the video clips called transformation, graphing transformation. Explain that idea. Okay. So in general, if you have the vertex at a comma k, the general formula will be, keep in mind that whenever you see a y, you change to y minus k. Whenever you guys see an x, you change to x minus h. You have this 4p y minus k equal to x minus h squared. So what does that mean? You have the same graph, but just shift to the new position. Let me use green color. If h is right here, k is right there, your new graph is going to be exact same shape. Just shift to the right, h unit shift up, k unit, yeah, it'll be right there. That's all. And same idea for the other graph. So the new one right here will be negative 4p y minus k equal to x minus h squared. Again, you have the graph right here. If a is positive and k positive, move to the right and move up, or could be moved down, move to the left, whatever. Depends on the value of h and k. That was the general formula. And this one going to be 4p of x minus h equal to y minus k squared. And the last one is negative 4p x minus h equal to y minus k squared. Okay? Those are the 4 main formulas for the parabola section today. Okay? Now, let me show you some applications that you may see in your homework. Some exercises, make it that way. First type, so number 3, all right. Some exercises. I'll give you a bunch of examples, help you to do the homework. I'm gonna give you an equation. Say ax equal to y squared. Looking at the equation, they're going to ask a couple of questions. What kind of parabola is this? Is that up, down, left, right? What is the p-value? Okay, etc. I'm going to answer all the questions. The key to figure out is what? Look, which one is square? This is y squared, right? So if x squared is going to be up and down, y squared is going to be left and right. Any positive, any negative? No negative. So this is a graph it's going to be. Okay, it's going to open to the right. And what about the p-value? So this equation looks like 4px equal to y squared. And match up with what we have is ax equal to y squared. All right, so from this you can calculate p. and here P equal to 2. Why P equal to 2? Because 4P is equal to 8, right? Match up two numbers right here. Okay, so P is equal to 2. Means 2 somewhere, so 2 is right here. So the focus is going to be at 2, 0. The directed line going to be vertical line x equal to -2. -2 right here. Keep in mind, directed is a line, okay? I'm not saying that this is a value. I'm saying this is the equation of a line. X equal to -2 is the equation of the line. Okay? Of course, in here the vertex is at 0, 0. So pretty much. How about another one? If I give you this, -4 y minus 2 equal to x plus 1 squared. Alright, now this second example is more general than the first one. Okay, so this one looks like the one that we learned before, -4 y minus k equal to x minus h squared. And this second example right here, the x term squared, the y is not squared, and I have negative in front. So if x squared, you have up and down, up or down. The negative, we have a downward problem. Okay, problem is going to be downward. Okay, where is the vertex going to be at? So h here is going to be -1, and k is 2, right? Y minus k, y minus 2, so k is 2. Y minus h here is the same thing as x plus 1, so like x minus -1, okay? So the vertex is at -1, 2, okay? So I guess the graph going to somehow be like this. X-axis, y-axis, -1 here, 2 here, this is the vertex, all right? What about the p, little p? This is for -4p. Okay, I'm sorry, I missed the p right here. And so obviously in this case, -4p is the same thing as -4, so p is equal to 1. Keep in mind that p will always be a positive number because p representing the distance. P is the distance, okay? So it's always positive. P is 1. All right, so it's going to be right here. P is the distance from the vertex to the focus, right here. Distance from here to here is 1. So this focus F is at -1, -1. See 2 right here, so down 1. -1, positive 1, I mean. -1, positive 1, all right? -1. This is the focus. All right, so you know P is 1, you go from the vertex, go down 1 unit, you're going to focus, all right? From the vertex, you go up 1 unit, you're going to have the directrix line, okay? And that directrix line equation is going to be, this is 2, go down 1, you got 1, go up 1, you got 3. This is going to be y equal to 3, equation of the directrix line, okay? All right, so in here, you go always try to stick with definition. Definition say what? Parabola depends on 2 things: the point, focus, directrix line, B. Okay, parabola always stay in the middle, always like that. Okay, that's one type of problem. We give you the equation and ask you to figure out all the information is parabola. The other way around. This time, give you some information and ask you to figure out the parabola. Okay? So ask you this. Another example, another type of example. Given the focus is at 2, 1, and the vertex is at 3, 1. Okay? Find the equation of the parabola. The best way is to sketch a graph. See what you got in there. Okay, so this is what we have. X-axis, y-axis. The focus is at 2, 1. 2, 1 right here. And the vertex is at 3, 1. This is the focus, and this is the vertex. With that much of information. You got focus on the left, vertex on the right. You know right away that parabola is going to open to the left, right? And the distance from focus to the vertex is P. So from here to here is P. In this case equal to 1 because 0, 1, 2, 3. 3 minus 2 is 1. Okay, so P is equal to 1. Okay. We're good? Can you figure out the directed line? It's P is 1, right? From the vertex you go to the right 1 unit. This directed line right here. There's that x equal to 4. Parabola is going to open to the left, somehow this way. Let me try to sketch and graph a little bit more precise. So P is 1. So latest spectrum going to be 4, right? 4P. 1, 2, 1, 2. You go from the focus, you go up 2 units, you go down 2 units, you got the latest spectrum. So parabola is going to be this. Okay? How do you figure out the equation of parabola? Look at the 4 type of equations that you have. This is open to the left, so it's going to be negative 4px minus h equal to y minus k squared. Open left or right, y squared. Okay? And x linear. And we have 4p negative because it's open to the left. Alright, now you got to figure out h and k. You know that vertex right here, h is 3. K is 1 and P is equal to 1, but the formula is, let me write down here, P is 1, H is 3, and K is 1. So this formula will be negative 4 times 1 is just 4, and then X minus 3 equal to Y minus 1 squared. And this will be your equation of the parabola. And if you want to factor out, simplify, go ahead and do it, but I'd rather not necessarily. This is good enough. Okay? How about another example? Give you f is equal to 2, 1, focus, okay? And then I give directed line at, say, y equal to negative 3. My second example, given the focus is at 2, 1, and the directed line is at y equal to negative 3. Keep in mind, this is the equation of the horizontal line, okay? So let's sketch the graph, see what we got in here. 1, 2, 3, 4, 5. 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. Origin is right here, x-axis, origin, y-axis. We have the focus is at 2, 1, x is 2, y is 1 right here. This is my focus. The directress line as y equal to negative 3, negative 1, negative 2, negative 3. This is the directress line. So the line is right here. The focus F is up there. You know for sure that your parabola will be open upward. Okay? And how far is the distance from the focus F to directress line? This is 1. This is negative 3. So the distance will be 4 units. Right? 1, 2, 3, 4 units. And you know that the vertex is always right in the middle of the focus F and the line D. So the vertex will be at 2, negative 1. Negative 1 is right in the middle of 1 and negative 3. Okay? Are we good? This is what we do. 1 plus negative 3 divided by 2. Negative 2 over 2, which is negative 1. The average of the 2 points. Take to the middle point. Okay? So the vertex is at 2, negative 1. You got the vertex already. Can you calculate the p-value? In other words, the distance from the focus to the vertex, or distance from the vertex to line D. It's 4 total, so that distance is going to be 2. So bit of p is equal to 2. Okay? And I claim